All right, so today is the start of chapter 13, and we will be exploring periodic functions. If you think about the scenarios that are happening here, perhaps the height of this girl as she's swinging along her swing, or the height of the wave as it goes up and comes back down, and goes up and comes back down. This function that I'm drawing right now is considered a periodic function. So by definition, a periodic function is a function that repeats a pattern of y values at regular intervals. One complete pattern is considered a cycle. So for example, this girl, if she starts at the bottom, her height goes up and then she comes back down to the bottom, that's one full cycle. And the period of the function is the distance along the x-axis of the cycle. So keep those things in mind. We'll obviously get a little bit farther into them in a second. So these first two are examples of periodic functions. It's asking us to identify the cycle in two different ways. So one thing that my instinct is to start like at a peak, and I know that a full cycle is going to go all the way to the next peak. So this blue outline is one full cycle of this graph. Whereas you maybe instead wanted to start at a minimum and go to the next minimum. So this red outline is also considered a cycle of the graph. And when we're talking about the period is, again, the distance along the x-axis for one cycle. So for the blue guy, it was from -3 to 1. Well, the distance from -3 to 1 would be a period of 4. You'd get the same thing if you looked at your red cycle. From -1 to 3 is also a distance of 4. So our period for this graph is 4. Similarly, in this guy, we could pretty much do the exact same thing. So take a moment and tell me, what is the period of this function? So in order to do so, again, we would have had to have identified a cycle. So here would be one cycle. The directions obviously ask for 2. So again, minimum to minimum would be another cycle. No matter which one you're looking at, you should get the same period. So -1 to 2, that distance here is a distance of 3. So the period for this graph is 3. Hopefully that's what you got. This next example is just saying, is the function periodic or not? So in this case, this first one, it definitely is not. Even though it's got this wavy thing, because it's on a slant, there is no actual period. You might be able to try and identify a cycle, but it's not going to have the same period each time. So he is not periodic. Whereas this guy is. You can see this repeating pattern. Again, if I highlight this, one cycle, or you could have another cycle from minimum to minimum or 0 to 0. But in this case, we do have a repeating cycle, and I would have a period then. You got to be careful, from 0 to 10. My period would be 10. So slightly different perspective now. Instead of looking at the graph, knowing that the period of a function is 4 seconds, how many cycles does it have in 1 minute? So we're talking seconds, which means there's 60 seconds in 1 minute. Each period is 4 seconds long, so there will be 15 cycles throughout the 1 minute. What is the period of a function that has 180 cycles in 1 minute? So this is a little bit different. I know that, again, there are 60 seconds in 1 minute. I know that there's 180 cycles. The reason I write it like this, notice my units, seconds per cycle. That's what a period is. This was 4 seconds for each cycle. So seconds per cycle, I set it up as 60 divided by 180, or it'll be 1/3 of a second for each period. So that vocabulary will hopefully get easier as we use it more often. Some more vocab to think about is every periodic function has an amplitude. So the amplitude of a periodic function measures the amount of variation in the function's values. AKA, we're looking for the distance between your maximum and minimum values, and we're going to cut it in half. So if you look at this graph here, the maximum value of this graph is along here at a 3. The minimum value of this graph is down here at a -1. So the distance between those two is 4 units. Now amplitude again is technically half of that. So our amplitude in this case is a 2. Another thing to note on this graph is what they're calling the midline. So after I'm highlighting my maximum and my minimum, the midline is the line located halfway between them. So it's going to be this horizontal line halfway between your max and your min. So to be a little bit more formal about it, the midline is the horizontal line midway between the max and the min, and the amplitude is half the distance between the max and the min. So you can think about it like this. Find your maximum value, which in our example above was 3. Oops. And the minimum value, which in our example above was -1. So technically we could have taken 1/2 3 minus a -1, and that's where we got the 2 that we were talking about earlier. So if you look at these graphs, it's asking us to draw the midline of each periodic function, to find the amplitude of the function, and the equation of the midline. So if I look at this first graph, I can see my maximum up here at a 2, my minimum down here at a -2. So halfway between those would be at 0. So my midline is at y equals 0, aka the x-axis. And then my amplitude, again, you can think of as half the difference between the max and the min. It's also going to be the distance between your midline and your maximum, or the distance between your midline and your minimum. Those should be the same value, and that will give you your amplitude. So in this case, my amplitude is a 2. Looking at B, we could do something similar. So I've got a maximum up here at 1, a minimum down here at -2. So your midline is halfway in between those, which is going to be this guy right here. Halfway in between a 1 and a -2 is actually a -1/2. So y, our midline, is y equals -1/2. Your midline's always going to have y equals because he's always going to be a horizontal line. You just need to figure out what the value is after. So halfway between 1 and -2 would be a -1/2. My amplitude then, I can find either by thinking about the distance between my midline and my maximum, or midline and minimum, or we can use our formula, which is 1/2 the maximum value of 1 minus the minimum value of -2. So again, this minus a negative becomes a plus, and I find out that my amplitude is 1.5. For C, this graph looks a little more funky, but it's the same process. So you have a maximum up here at 5, you have a minimum down here at 0. Halfway between those would be at 2.5. So that's my midline, y equals 2.5. And then that will also actually be my amplitude, because we have that distance between the max and the the max and the midline, the mid and the midline. So why don't you guys look at D? I want the equation of the midline, and I want the amplitude of the function.